This video will cover beginner questions part 2 regarding the topic of trigonometric substitution. We learned trigonometric substitution using x equals a in sine theta in part 1. Now let's learn how to find the integrals when the expression x equals a tangent theta is involved. Question 1. X equals 2 tangent theta, derive on each side. Dx equals 2 secant squared theta d theta. The integral of dx equals this 2 secant squared theta d theta over 4 plus x squared. X is 2 tangent theta then squared. The denominator 4 plus 4 tangent squared theta equals, we can factor 4 1 plus tangent squared theta, that means 4 secant squared theta. If you can remember this formula, how about this? Sine squared theta plus cosine squared theta equals 1. Then divide by cosine squared theta on each side. Then tangent squared theta plus 1 equals secant squared theta. Then back to the original, the integral of 2 secant squared theta d theta over the denominator 4 secant squared theta equals 2 times 1, 2 times 2, 1 over 2 here. Then secant squared theta is cancelled. D theta, nothing means 1. Then integrate 1 over 2 times theta plus c. Then from here, 2 tangent theta equals x. Then divide by 2 on each side. Tangent theta equals x over 2. Then take arctangent at both sides, like this. Then theta equals arctangent of x over 2. Then back to the original, 1 over 2. Theta means arctangent of x over 2 plus c. Question 2. X equals 2 tangent theta, derive on each side. Dx equals 2 secant squared theta d theta, and 4 plus x squared equals 4 plus x squared, which is 4 tangent squared theta. Then we can factor, take out 4, 1 plus tangent squared theta equals 4 secant squared theta. Back to the original, the integral of dx equals 2 secant squared theta d theta over 4 plus x squared is here, 4 secant squared theta squared equals the integral of 2 secant squared theta d theta over 16 secant to the power of 4 theta. Then 2 times 1, 2 times 8, 1 over 8, integral of cancelled, the square is left over, then 1 over secant squared theta d theta equals 1 over 8 integral of, we can rewrite as cosine squared theta d theta equals 1 over 8 integral of, the power of cosine is even, use the half angle identity for cosine, 1 plus cosine 2 theta over 2 d theta. Then together 1 over 16 integral of 1 plus cosine 2 theta d theta equals 1 over 16 theta plus, do you remember the formula? The integral of cosine x dx equals sine x plus c, the integral of cosine kx dx equals sine kx over k plus c. Then in here, k is 2, then sine 2 theta over 2 plus c. From here, divide by 2 on each side, x over 2 equals tangent theta, then theta equals arctangent of x over 2. Then back to the original, 1 over 16, then theta equals arctangent of x over 2 plus, now use the double angle identity, sine 2 theta means 2 sine theta cosine theta over 2 plus c, 2 is cancelled, then 1 over 16 arctangent of x over 2 plus, consider the situation where the ratio of the tangent theta is x over 2, then draw the right triangle where the respect angle is theta, then we label x and 2 here, because the tangent ratio is the opposite side over the adjacent side, and use the Pythagorean theorem, c squared equals 2 squared plus x squared, then c equals square root of 4 plus x squared. So hypotenuse is square root of 4 plus x squared. Then use this triangle. Sine theta is opposite side over the hypotenuse, which is x over square root of 4 plus x squared times cosine theta is 2 over square root of 4 plus x squared plus c. Then final answer is 1 over 16 arctangent of x over 2 plus 2x over 4 plus x squared plus c. Question 3. X equals 2 tangent theta, then dx equals 2 secant squared theta d theta, and then 4 plus x squared equals 4 plus x squared is 4 tangent squared theta, which is 4 secant squared theta. We know it because we have already used it. Then 4 plus x squared then squared equals 16 secant to the power of 4 theta. Now let's put them all together. The integral of x equals 2 tangent theta dx equals 2 secant squared theta d theta over the denominator is 16 secant to the power of 4 theta equals 2 times 1, 2 times 8, then 2 times 1, 2 times 4, then 1 over 4, integral of tangent theta, then cancelled, 2 is left over, then secant squared theta d theta, then tangent theta over secant squared theta equals tangent theta times cosine squared theta. Then tangent is sine theta over cosine theta times cosine squared theta over 1. Then cosine is cancelled. Then sine theta times cosine theta. Then 1 over 4 integral of sine theta cosine theta d theta. Then there are two ways from here. The first, let u equal sine theta, then du equals cosine theta d theta. Then 1 over 4 integral of sine theta is u, then du equals 1 over 4 u squared over 2 plus c equals u means sine theta, then sine squared theta over 8 plus c. And do you remember the right triangle we used in question 2? The opposite side is x, adjacent side is 2. Then use the Pythagorean theorem. The hypotenuse is square root of 4 plus x squared. Then 1 over 8 times sine means x over square root of 4 plus x squared, then squared plus c. The final answer is x squared over 8 times 4 plus x squared plus c. The second, let u equal cosine theta, then derive on each side. Du equals minus sine theta d theta. That means minus du equals sine theta d theta. So start here. 1 over 4 integral of u equals cosine theta, then sine theta d theta equals minus du, then minus 1 over 4 times u squared over 2 plus c, then minus 1 over 8 times u squared, u was cosine theta, plus c equals minus 1 over 8. Use this triangle. The cosine theta is 2 over square root of 4 plus x squared, then squared plus c minus 1 over 8 times 4 over 4 plus x squared plus c. Then final answer is minus 4 times 1, 4 times 2, 1 over 2 times 4 plus x squared plus c. This is the last one. X equals 2 tangent theta, then dx equals 2 secant squared theta d theta, and then 4 plus x squared equals 4 plus x squared, which is 4 tangent squared theta equals 4 secant squared theta, and 4 plus x squared then squared equals 16 secant to the power of 4 theta. We already know everything here. Now let's put them all together. The integral of x squared, which is 4 tangent squared theta, then dx equals 2 secant squared theta d theta over the denominator is 16 secant to the power of 4 theta equals integral of 4 times 1, 4 times 4, then 2 times 1, 2 times 2, then 1 over 2 tangent square theta over cancelled, 2 is left over, secant squared theta d theta equals 1 over 2 integral of tangent squared theta over secant squared theta equals, the numerator is sine squared theta over cosine squared theta times 1 over secant squared theta means cosine squared theta, make over 1, then cancelled, sine squared theta. Like this. Equals 1 over 2 integral of, the power of sine is even, use the half angle identity for sine, which is 1 minus cosine 2 theta over 2 d theta, then 1 over 2 times 1 over 2 is 1 over 4, the integral of 1 minus cosine 2 theta d theta equals 1 over 4 times theta minus, do you remember the formula? The integral of cosine kx dx equals sine kx over k plus c. In here, k is 2, then sine 2 theta over 2 plus c equals 1 over 4 theta minus, use the double angle identity, sine 2 theta means 2 sine theta cosine theta over 2 plus c equals 1 over 4 theta minus 2 is cancelled, sine theta cosine theta plus c. We must return to the original variable x. Do you remember the right triangle with the respective angle at theta? And then from here, divide by 2, then tangent theta equals x over 2, then theta equals arctangent of x over 2, then back to the original, 1 over 4, theta means arctangent of x over 2 minus sine theta is x over square root of 4 plus x squared times cosine theta means 2 over square root of 4 plus x squared plus c, then final answer is 1 over 4 arctangent of x over 2 minus 2x over 4 plus x squared plus c. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.